Everyone, welcome to another episode. So apparently, Leetcode, we completed our April month's challenge, and Leetcode has started another challenge for the May month. And again, as you can see, I'm behind, and this time they have added a rule, like they have added a new feature where they show that you have passed the deadline, and so it won't be counted. And you see a cross sign here. Um, but still we are gonna solve it because it's just that we love coding and we like to solve complex problems. Who cares about points, right? So let's move on with this question. The question is first bad version. So you are a product manager and you are in a team, and unfortunately the latest version of your product fails quality checks. So since each version is developed based on previous version, all the versions after a bad version are also bad. So suppose you have n versions, you want to find out the first bad one, right? Which causes following ones to be bad. So you're given an API is bad version, which will return whether the version is bad or not. So we can just make use of this one method. Implement a function to find the first bad version. You should minimize the number of calls to the API. So let's say in the given example, n is 5 and version is 4, right? Bad version is 4. So let's say I give a call to 3, it give me false. That means it's not a bad version. I give a call to 5, it gives me true. That means 5 is a bad version. But there is a possibility that any number before 5 could also be a bad version, right? And if we call 4 and we get the bad version, right? So then 4 is the first bad version. One way would be we need to minimize the number of calls. One way would be we are given n, so we call each and every version from 1 to 5 in a linear order, like 1 and then 2 and then 3 and then 4 and 5. But that would take time complexity of O of n, and that's not what we want. Let's see what we can do here. So I guess simple visualization for this example, n is 5 and fourth version is the bad version. So I'll just write the numbers here, 2, 3, 4 and 5, right? So this is the bad version, we know. Now how do we solve this? Let's say the thing that comes to my mind is how about dividing it into two on each step, right? So let's say there is 5. So I divide 5 by 2, I get number 2.5, which is equal to 2, let's say. So I hit 2. I check whether this is a bad version. This is not. So I know then anything previous to 2 is all good. Anything after 2 could is contains the first bad version, right? Because 2 gave us false. Now I have 3, 4, 5. Now I split this, and now I've got this section. So I query mid of 3 and 5, which is 4, and 4 gives me a bad version. So uh, I so if 4 gives me true, right, then I take 4. I maybe I store it in a variable, let's say first bad version equal to 4. But there is a possibility that okay, so 4 is bad, so I know anything after 4 is bad, so we just scrap out this section, right? Now there is a possibility that any number previous to 4 could also be bad, right? So I cut this half and I try to uh, uh, what we say call or evaluate the left half of the 4, and then I hit 3, so that gives me false. So we already have stored 4 in our first bad version, so I'm going to return that. In a way, I'm doing a binary search, so I'm doing a divide and conquer. So at each step I try to divide it into half, and if I check whether at that midpoint I get true or false. If I get true, then I no, so if I get false, then I know that the right side has my first true or first bad version. If I get true for a midpoint, then there is a possibility that left side of that midpoint contains the first bad version. Let's look into the code. So I'll try to use Java. So my int start would be 1 because we start with 1. Int n is equal to n while start end. Come to I take it doesn't say that there will be an invalid case. That means there is gonna be a first bad version present in this whole version list. Okay, so my mid would be start plus if is bad version of mid. So if it's a bad version, then I just store version to be equal to mid. It's, and then there is a possibility that my left side could have the first bad version. Else I do start is equal to mid plus 1. Then I just, if I get false, then I know my first bad version is on the right side, and I simply do start. And then I return first. I think it should be start less than equal to end as well. Let's run this code and see. Time limit exceeded. That means we can do better. So that means binary search won't be the one efficient in this case. What else can we do? Okay, let's say I try to solve this in C++. Awesome. So I guess it's faster in C++ and it got accepted. I think so. I don't know why it didn't work in Java, but it worked in C++. Generally, that's why for competitive programming I use C++. But yeah, this is the best approach I can come up with, that you can just divide and conquer and try to hit the API. But I'll try to brainstorm if I can do faster so that the Java solution also gets accepted. Hope you guys like this video. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.